The next thing we're going to be doing in the unit is graphing exponential functions. So if you look at your notes, it shows you the parent graph is y equals b to the x. B is always a number, but it could change. It could be 2 to the x, or 3 to the x, or 4 to the x, or 5 to the x. It could even be fractions, 1/3 to the x, 1/4 to the x. And depending on the base, the graph is going to look a little bit different because it will be growing at a different speed. But for all of the exponential graphs, there are 3 pieces of important information. So the first piece of important information is the y-intercept. That's what you get when you plug 0 in for x. And if we consider this, if I put 0 in for x right here, it's always going to be as an exponent. And b to the 0, it doesn't matter what b is. Whenever I plug in 0 as an exponent, that always equals 1. So the first point we always know is that if I plug in 0 for x, since that is an exponent, I will get 1 for the y value. That point shows up on every single exponential graph you will ever do. The second thing I know is that if I plug in 1 for x, a base to the exponent of 1 is just whatever number the base is. So 3 to the 1 is 3, 4 to the 1 is 4, 1/2 to the 1 is 1/2. And so that's another piece of information we will always know, is if I plug in 1, I'm going to get whatever the base is. The third piece of information that I know is that it doesn't matter what I plug in right here. There is no way for me to do an exponent, a base to an exponent, and get a negative value, or to get 0. Because remember, if I plug in negatives for my exponents, all that it does is turn the number into a fraction. There's no way to do like 2 to the -5 equals a negative number. 2 to the -5 is 1/32. So there's no way for y to equal 0 or for y to equal anything negative, which means we have an asymptote, or a line that cannot be crossed, at y equals 0. And in parentheses next to this, go ahead and write that's a horizontal asymptote. It's a horizontal line that cannot be crossed. So those important pieces of information are going to be in every single graph we have. So we're going to go ahead and graph an example. Write this down, y equals 2 to the x. We have to choose a base to be able to graph it. So the first thing I'm going to do is draw in my asymptote at y equals 0. This is a line that's not going to be crossed on our graph. The second thing, remember, 0, 1 is a point that's on every single graph of these. So here's the point 0, 1. And then the next point is 1 for the x-coordinate, and the y-coordinate is whatever the base is. So in this case, it would be 1, 2. And so here is what the parent graph for y equals 2 to the x looks like. And exponential graphs are going to have that general shape. They're going to grow really quickly. This end of the arrow right here is getting really, really close to this asymptote. So as you go, it's going to get closer and closer, but never cross it. And then the other arrow, this one up here, is just going to grow really, really quickly, because it's going to be 2 to the first, which is 2, and then 2 to the second, which is 4. That one's right here. And then 2 to the third, which is 8 up here. And then it's going to keep growing more and more quickly. Actually, I guess that would have been like right there. Anyway, you get the idea. It's an exponential graph, so it grows exponentially, which is very, very quickly. All right, how do I transform exponential functions? It's going to feel very similar to what you have done before. So go ahead and write a times b to the x minus h plus k. So the number in the front is going to be a stretch, or a compression, or a flip. So remember, flips are anytime you have a negative number. A stretch is going to be when a is greater than 1. And I'm going to go ahead and put absolute value signs around this. It technically should always have been there. So if you have -5, that's a stretch. If you have -6, that's a stretch. If you have +5 or +6, those are both stretches as well. So it doesn't matter if the number itself is positive or negative. The fact that the number is bigger than 1 in value means that you have the stretch there. Compression are going to be for a values that are between 0 and 1, so those are those fractions, 1/2 or -2/3 or whatever. That's what the absolute value means. It doesn't matter if it's positive or negative, it's still a compression. For b, make sure you note this b is not a transformation, it's the base of the exponent. And students forget that a lot, and then they call it a stretch, and it's not. So the base of the exponent, it tells you what exponential graph you're going to be drawing. So be really careful of that. Maybe make it in bold, maybe underline it, something like that. This number right here, just like normal, is left and right. Positive values show you left, negative values are right. And then here we have up and down. Positive values go up, negative values go down. Now, when we graph these, there's not like a good shortcut since all the bases are different. We would have to memorize a lot of different graphs to be able to do shortcuts for when we graph these by hand. And so what we're going to do is we're actually going to draw charts to graph them. And you'll see the chart in a minute, but we need to think about a few things first. So here's the first thing we're going to think about is when you flip, if I have, you do not have to draw this picture, but if I have a point up here, and then I flip it down here, you'll notice that the x value, this is the x value, is from left to right. The x value is exactly the same. Both of those are going to the right, so both of them would be positive. The part about this that's actually different is the y value. Here the y value is going up, so it's a positive value. When I flip it, it's going down, so it has become a negative value. So when we flip points, the y value changes signs. So change sign of y value. That's what happens when you flip. So the x value stays the same, the y value changes. Next, when I stretch or compress, it makes the graph more or less skinny. So normally if we had a parabola, that would look like that. If I were to compress the graph, that would squish it like this. And so let's say maybe here there was a y value of 2, but down here the y value is 1. It makes it seem squished. And my graph is not perfect. Those red marks shouldn't be going further to the right or left. So this green point right here would become this green point right there. Oh, that's a terrible sketch. But basically what's happening is the x value is not being affected, it's only the y value. So whatever your stretch or your compression is, you multiply that number by the y value. So if your compression was 1/2, you would take the y value and multiply it by 1/2, and that would tell you your new y value. If the graph was being stretched by 2, you would multiply the number by 2, and that would tell you your y value. The next one is your left-right movement, and this one should seem obvious. If you're moving a point to the left and to the right, you're going to do that with your x-coordinate. So for the left movement, you're going to be subtracting. For a right movement, you're going to be adding to your x value. And then last, up, down, this one is going to be changing your y value. So if you're going up, you're going to add. If you're going down, you're going to subtract from the y value. All right, so next it says, how do I graph them? First, we're going to start off by making a chart. So you have a chart on your paper. And the first thing we're going to put in the chart is that we know we have the point 0, 1. I'll go ahead and write the equation since it's not written down on my slide. The second thing is I know if I plug in 1 to the parent graph, I would get the base. The base of this graph is 3, so I'm going to go ahead and write 1, 3. And then I always start off with that asymptote at y equals 0. So now I'm going to walk my way through all the transformations. The first transformation I see is a flip. That's going to take the y-coordinate and change the sign. So the y-coordinate of 1 is going to become -1. The y-coordinate of 3 is going to become -3. If I flip, that asymptote has not changed at all because it was exactly in the middle. So y equals 0 is not affected by a flip. Underneath, it would be good to write in your notes that what you did here is you flipped, just so if you need to look back at it and see what you did in the future, you know exactly what it was. The next thing is the +2 up here, so that means that I'm moving left 2, which means I'm going to take my x-coordinate and subtract 2 from it. That's how we move to the left, as we subtract numbers. So 0 minus 2 is going to be -2. The y-coordinate stays the same. 1 minus 2 is -1, and then the y-coordinate will stay the same. The third thing is a horizontal asymptote. Those only move up and down. So when I subtract 2, it does nothing to it. All right, and then last, I'm going to be subtracting 1, and that's moving down. So I'm subtracting 1 from the y-coordinate. So it's going to be -2, -2, -1, -4, and then that horizontal asymptote will now be moving down, so I'm going to write y equals -1. So we'll go ahead and graph this. I'll start off with the asymptote, -1. And then we'll graph the point -2, -2, and -1, -4. So there's -2, -2, -1, -4. We'll make it look like an exponential graph, because we always know this part is getting closer to the asymptote and this part is growing really quickly. And so that's what our graph would look like there. So next, if we're going to answer how do I find the domain and range, first we need to look at what's happening to the graph as you go left and to the right. So to the left I see an arrow, to the right I see an arrow, and so I'm going to go ahead and show that the domain is from -infinity to +infinity. And I can see like this arrow would mean it's going to go forever to the left. This arrow means it's going to the right forever, not very quickly, but it's still doing it. For the range, I have to consider what's happening as I go down. So down is an arrow, and up, even though it has an arrow, it's going to stop at that asymptote. It can't go past it. So for down, I have -infinity, but for up, I have -1. So the range is going to be from -infinity to -1. And if you need to write a note to yourself, you could write the asymptote affects the domain and range. That would be a good note to write. So asymptote affects the range. Next on your notes it says, how do I find the increasing and decreasing intervals? If you look at this picture, it's definitely decreasing. That would mean that for the increasing intervals we have none, and for the decreasing intervals it goes from -infinity to +infinity. We're going to look at how do I find the intercepts. We're going to graph this on a calculator, and then we're going to look just like we normally do. Now you should be able to see that definitely there's not going to be an x-intercept because we never cross the x-axis, but there is a y-intercept. When you plug in 0, you get -10. So for the x-intercept, I'm going to say none, and then for the y-intercept, I'll say 0, -10. And just like normal, make sure when you answer those that you write the answer as a coordinate, an x and a y, not just the x value or the y value, always as a point. And then last, it asks about the local max and the local min, and the answer is there aren't any because there are no hills and valleys. Sorry, none, no hills or valleys. I think I was going to combine those as one word. Hillies, hallies. The next example in your notes we'll go over at the beginning of class just to make sure that everything made sense.